All right, guys, we're moving on to the second section of our chapter here, 8.2, multiplying monomials and polynomials. I can multiply monomials by polynomials and then simplify the expression. So this is not really going to be that complex, but we're actually we're going to start moving into some higher exponents, some things maybe that you may or may not have seen. So we're going to go over some exponent rules and talk about like terms and some of that stuff as well. So let's just jump right in and look at a few examples here. We'll call this one example 1. And we've got 4, and we've got a parenthesis, 5x minus 9. Okay. So one of the first things we got to think about and talk about is if we have and again, this is a monomial times polynomial. So a monomial is just one term. All right. Mono means one. And then polynomials can actually have a various number of terms, exponents, variables, whatever the case may be. So really, this is a really general term here, and you're going to see that we're going to do a couple of different examples here. But basically, this would be a binomial, okay, because it has two terms. So a bicycle has 2 wheels. A tricycle has 3 wheels. So you kind of get the idea of kind of how this goes. So anytime we've got a number right beside of a binomial like this, and we've got parentheses here, we understand that there is multiplication here, okay? Well, the other thing I want you to understand is that this 4 is being multiplied not only by the 5x, but it's being multiplied times the negative 9 as well, okay? So because this is right beside of this, and this is one complete unit by the terms of these parentheses, then I have to understand that I've got to multiply by both. So obviously we have seen things like this before, and we would know that we need to do what's called the distributive property. So I need to multiply this 4 through the 5x, and I need to also multiply it through the negative 9, okay? So I'm going to do 4 times 5. I'm just basically going to start with my coefficients first, which are the numbers in front of the variables. So 4 times 5 would be 20, and then the x kind of just comes along for the ride, okay? So then we would have 4 times negative 9. So positive 4 times negative 9 is going to be negative. We can go ahead and kind of settle that sign first. And then I've got 4 times 9, which would be 36. Now, one of the things we have to talk about is can I go ahead and combine this part now? Okay, and a lot of people, they may try to take this 20x minus 36, and they may make this, say, negative 16x, okay? I'm going to go ahead and tell you that that is not true, okay? You cannot combine these two things because they are not like terms. And so let's have a little discussion about like terms. Like terms, okay, like terms have to have the same variable, okay? They have to have the same variable, and they have to have the same power, or I'm going to use another word here, index, okay? So in other words here, this term here, and I'm going to circle it in blue, has an x with it. However, this term here, which is a negative 36, actually does not have an x with it. So those cannot be combined because this one has a variable and this one does not, okay? So I would have to just leave my answer the way it is. 20x minus 36 would be my answer, all right? So now let's move on to second example here. So example 2, we have x squared times negative 3x plus 8. So real similar in the fact that I have, again, a monomial that's being multiplied by a binomial. So I'm going to do exactly the same thing again. I'm going to distribute these through, but we're going to have a little bit different discussion this time, okay? So again, I'm going to always try to look for my coefficients. Well, what's in front of this x squared even though I don't see it? We know that there is a number 1 right there. So I'm going to take 1 times negative 3, which is going to give me negative 3. And then I've got x squared times x. Now I want you just to think about that for just 1 second. X squared times x. Now what power is this x here being raised to? It's being raised to the first power, right? Because I only have one of those x's right there. So when you take x squared times x, common sense would say, well, x squared times, or 2 times 1 is 2, so this should be just x squared. Okay, but that's not actually the case. Let me show you, let me expand this out, and it will help us, I think, to see this. Think about what x squared really is. This 2 tells me that I'm going to repeat this x twice. So that means this is really x times x. that's the same thing as x squared, times 1x. Okay, now I want you to count how many x's you have. You have 1, 2, 3 of those x's. So you've got x times x times x. Well, x times x is x squared. So x times x is actually x to the third. Okay, so this is not true here, obviously. But what you do when you multiply exponents, okay, when you multiply exponents, you actually add them. Okay, when you multiply exponents, you actually add them. So in other words, if you had x squared times x to the third, again, that is not x to the sixth, okay, but you're actually going to add these two exponents together. And again, we can kind of expand that out so you can see it. So x squared times x to the third is actually 5x to the fifth, okay? So we add the exponents. So now that we've got this here, x squared times x to the first is actually going to be x to the third, okay? Plus x, 1 times 8 is 8, and the x squared, again, kind of just comes along for the ride. And again, we have this discussion about like terms. Do we have any like terms here? Well, actually, we do not, because this is being raised to the third power, and this is raised to the second power. So this would be my answer right here. Just like this had to just kind of stay the answer on number 1. So let's look at another example. This time we're going to throw in some more variables. Okay, so now we've got x squared y times 3xy plus 5x. Okay, we got one more example after this, so just kind of hang with me here, and we'll get through this pretty quickly. So again, I've got a monomial being multiplied times a binomial, which means that I'm going to do the distributive property. And again, I'm going to ask myself, what's in front of this x squared? Well, it would be a 1. So 1 times 3 would be 3. And now let's think about our x squared term. So I've got x squared times x. X squared times x. Remember, that's to the first power. So when I multiply, I actually add, which means that would be x to the third. Okay? Now I've got y times y. So y times y, those are both to the first power. So that means it has to be y squared. So I end up with a term of 3x squared y, or x cubed y squared, okay? Plus 1 times 5 would be 5. Again, I've got x squared times x, which would be x to the third, but I don't have any y's, so I'm just going to kind of carry this y along with it. It kind of goes along for the ride. Now, again, we may question ourselves and say, okay, do I have like terms? Well, it does, in fact, you do, in fact, have a 3 here and a 3 here. But I want you to notice that here you have y squared, and here you have just y to the first, okay? So those are not like terms because they are all combined together, okay? A term is everything except the, in this case, the addition sign right here, okay? So your terms would be these parts, and those are not like terms. So again, once again, this would be my answer. All right, let's look at one more that you are going to have to combine some like terms on and kind of do a little bit of everything here. So we have 3 times 4x minus 9 plus 8 times 3x plus 2. And so again, we have monomial, binomial, monomial, binomial again. So I'm going to have to distribute these terms. 4 times 3 is 12x. 3 times negative 9 is negative 27. Then I have positive 8 times 3x, which would be 24x, and positive 8 times positive 2, which would be positive 16. So now let's talk about our like terms. We have a 12x here. We've got a positive 24x here. So that would make 36x. And then here I have a negative 27 and a positive 16. So that would in fact be negative 11. So this would be my final answer with all my like terms combined. Okay? So like terms, multiplying exponents, you actually add them. Again, we're really just doing the distributive property today. Tomorrow it's going to get a little bit more complex, not that much more complex. We're going to be multiplying binomials by binomials. So we're going to start seeing this quadratic part of this equation start to come out in full form. If you need any help, make sure to reach out to either me or Miss Wheeler, and we'd be glad to help you out with whatever you may be having issues with. Thanks.